welcome to my talk. I'm starting off the afternoon here, I guess. My name is Dalibor Topic. As you can see, it's a name from here. I was born in Black Forest. It's a typical Swabian name. I work for Oracle in Hamburg, though, in the north of Germany. So I enjoy coming down here every now and then to basically hear the wonderful sound of the local German. But when I don't do that, I work on Java at Oracle as a product manager. Oddly enough, on a product that isn't something that ships, I work on OpenJDK. I'll tell you a bit more about that as the presentation goes on. But I'm here to talk about Java in general and Java in the IoT context specifically. So before I get started, you may have had a chance to see presentations from my colleagues from Oracle before. Then you're certainly familiar with this safe harbor statement. If you're not, I'll give you just a bit of time to familiarize yourself with it. There won't be a test, don't worry. But it's the one slide that remains the same in any presentations you see from me and from my colleagues. Everything else may change. And with that out of the way, because you're all fast readers, I'm sure, in the next 30 or so minutes, we'll chat about a bunch of things. We'll talk about the anatomy of the Java platform, so what Java actually is technically made up of and how it's being made. Talk about what makes up such platforms, what different editions there are, and how they fit together. And then I'll talk quite a bit about OpenJDK, what it is, what its role is in the Java ecosystem, how it works and why it works. It's actually quite a successful open source community and slightly different from many others in many ways, I think. And finally, we'll talk about IoT quite a bit, and I'll talk about Java in the context of embedded systems and what makes it so great in the long run. But first, anatomy of the platform. And I should also say that I'm staying here during this presentation in place of Donald Smith, who was originally scheduled to do the talk, and he gave all the top-level ideas. And when he said anatomy of the platform, of course, I had to use this wonderful picture from Rembrandt of an anatomical course in 1600 something. But it also nicely describes the way Java is actually done. It's created by experts coming together to define and refine and implement specifications. In this case, the experts are being led by a spec lead, the guy with the hat. So he's in charge of improving something or other. There's an expert group contributing to the effort, and together they actually produce books. And Java is kind of special is in many ways from different platforms is that it's very much defined by two books. On the right, you see the Java Virtual Machine specification, which describes what the Java Virtual Machine does. And it's actually a book you can buy on your favorite bookshop. And the other one is the Java language specification, which describes how the language works. Tied together are both of them through the APIs, also defined of the Java platform specification requests. The specifications are developed as part of the Java community process. So Java has its own body that develops the specifications, and it also requires that such specifications, like the platform specifications, also come with a reference implementation. So with a bit of code that shows that the specification as designed by the experts is actually implementable and actually works. That's what's being developed as part of the OpenJDK community for Java SE. That's where we develop the reference implementation of Java SE platform specifications. There is a third part here, which is the technology compatibility kit, which is also quite specific to Java. In the terms of the specification requests, we also want to ensure that implementations are compatible so that you as a user can actually switch between them. And this test suite, the TCK, serves that role by enabling implementations to actually test and, if they're compliant, pass these test suites. So that's the anatomy on a large scale of how Java is being developed. On the small scale, though, if you go to java.com today, you'll just see one download telling you to go download Java here for Mac or Windows or something like that. Since we switched over java.com to feature Java 8 just a few weeks ago, right? And this is also one of the last steps towards the end of the public updates of Java SE 7 from Oracle, which is scheduled for the April 2015. So now that java.com has Java.8, all your users in their browsers will get directed to java.com to get Java 8. Developers, on the other hand, when they go to java.oracle.com, will have a few more options. They can choose between JDK, server JRE, and the JRE. So there's 3 options. What are the differences, and how do these things relate to the specifications? And there's this handy eye chart on the right that describes this in a bit. On the right-hand side, you'll see something that says Java SE APIs. So those are the APIs defined by the platform specification. They describe what sort of functionality every implementation of the Java platform has to provide. And those are things like Java lang classes, Java util classes, things like JDBC, great thing, JNDI, Swing, AWT, and so on. And one interesting new thing, in particular in the embedded and IoT space in 8, is that we have gone a small step towards modularity. So this is a small step for you as the users, but a big one for the JDK team. We have partitioned the set of SE APIs into different profiles, starting with a compact profile that just contains the lang and util and base libraries. On top of that, profile containing other base libraries, and then on top of that, another profile containing further integration libraries. No UI libraries, though. So basically, these profiles partition the Java SE APIs in ways that make it much nimbler and smaller and fit into smaller devices. You'll notice no profile downloads here. You get the full JRE. So what's the full JRE then? Well, from Oracle, JRE includes all the APIs in Java SE specification, of course. It has to. But it also comes with additional deployment tools, in this case, the plugin, applet support, Java Web Start, and so on. And then going further on top of that, there is the JDK, which includes development tools for working with the Java programming language. And you'll notice these are only part of the JDK. So the JRE and the JVM, they don't care about the language. All they care about are the bytecodes, which may be generated by the Java compiler, could be generated by a Scala compiler or a Groovy compiler. So the JVM is language agnostic. The Java development tools aren't. And there is this interesting thing that you may have noticed in between the JDK and JRE, which isn't the big picture, but it's on the left-hand side, the server JRE. So if you're just downloading a JRE to run service applications that don't need to have a plugin, you can use that instead. It doesn't have the deployment functionalities. So you don't have to care about installing it in your browser and so on. So as you can see, as a developer, you have more options, or as a sophisticated user, you have more options, in particular with Java 8, what you use. And some of these are smaller than others. And one of the interesting things has been how the platform has evolved over the past years to take such concerns about use in smaller and embedded systems more into account than it was the case in the past. And before we get there, let's look a bit into what kind of different platforms there are in the Java space. So I guess you're all familiar as Java developers, right? With Java SE, so the Standard Edition, that I was just talking about, and probably with Java EE, the Enterprise Edition, which is built on top of Java SE. And so today you have Java EE 7, which uses Java SE 7. In the JCP, the community around Java SE is working on Java EE 8, which would use Java SE 8. And the Enterprise Edition as well has the same concept. There is a specification. There is a reference implementation. In this case, it's Glassfish, maintained by the Glassfish open source community. And there's a TCK for that as well. But then going further down, there is a Java Platform Micro Edition. And it's not, as you may think, just a cut-down version of Java SE with some APIs left out. It actually has been further apart in the past, but as part of our work on moving Java forward, we have brought these platforms closer together. It supports a slightly different version of the Java language. It's now up to language features from Java 7 and contains a more pared-down set of base class libraries that are suitable for mobile and web applications and, for example, provide network protocols and security applications. And then going even further down, if you look at smart cards and very small devices, there is the Java card, which is also quite interesting in its own way. It's a very pared-down VM and API that can fit into kilobytes rather than just megabytes or hundreds of megabytes. And so how does OpenJDK fit into all this? So you may have heard about it as this open source thing, community project, something like that. And OpenJDK is quite interesting because, as I said, the reference implementation of the platform specification is something that's required by the community process. There has to be one. And since Java SE 7 for Java SE, it has been open source. This has been a trend that began by Glassfish back in, I think, 2005, when Glassfish was open sourced by Sun. And then OpenJDK was open sourced by Sun back in 2006, 2007. But only with Java 7 did it become the reference implementation of the platform specification. And so that has then continued to be the case for Java SE 8. So this March, we published the Java SE 8 specification as well as the REST implementation of it through OpenJDK. And then it's continuing to be the case for 9, where the JDK 9 project in OpenJDK is already working on the next major revision of the platform in the open with the community. And so OpenJDK, as its definition says on the OpenJDK Java.net page, is the place to collaborate on an open source implementation of the Java Platform Standard Edition and related projects. And as definitions go, each word of this sentence is important. It's the place. So it's where the infrastructure is. It's where the Mercurial service is. And we use Mercurial rather than Git. Sorry about that. It just works. It provides the bug tracking system. So all the things you need to develop an open source project are basically there. Even mailing list. And we use mailing lists a lot. They seem to provide a nice barrier to entry for people who only use forums. So that's, so that's good. It's also a place to collaborate. And this is also quite important because in some open source projects, you end up in a situation where there is basically only one organization participating and throwing stuff over the wall every now and then. And if you're lucky, it fits your purpose. If you're not, well, too bad for you. What OpenJDK enables us to do is to collaborate. So to have people from Oracle collaborate with people from Apple, for example, on an OS export. And so if you remember the good old days back in 2011, there was a moment of angst in the Java community. What would happen with Java on the Mac? And it turned out, well, Oracle would take over, right? Working together with Apple and the community to provide Java 7 and Java 8 and so on the Mac. And that happened through OpenJDK. It provided a place to collaborate on such implementation. It provided a place for, say, IBM and SAP to get together and collaborate on a PowerPC AIX Linux port of OpenJDK to the systems they care about. A place for Red Hat to collaborate with Oracle and others on Linux support. Even provided a place for Microsoft Open Technologies to come in a few weeks ago and contribute their first change to Java to fix something or other with networking, which is a thing completely, unexpected for most of us. If you asked me 10 years ago, you'll have Microsoft Open Technologies contributing to Java in 2014, I would have said, well, maybe not. But that's the way. If something works out, it actually works out quite well. And of course, that means the open source part is quite important as well. So the code in OpenJDK is open source, and we try very hard to make sure that people don't drag in non-open source dependencies, because it's the open source part that allows this collaboration to happen, that allows different parties to get together and work and share the results. It's implementation. So in OpenJDK, we work on code We don't work on specifications. We don't work on the TCK. We don't work on, I don't know, general social issues or something like that. We work on the code for the JDK. So it's a very technical focused community that way. And it's also about Java SE. And like I said, for Java EE, the Enterprise Edition, there is glassfish.org. So there is the Glassfish community where that's being maintained. OpenJDK is very much focused on Java SE, which by itself, as you've seen in the diagram, is a really huge thing. So there is a lot to do. There is the VM, there is the language, and there's all these different beautiful APIs to evolve and collaborate on. So it contains a whole bunch of very active projects. Projects like JDK 9, where we're working on the next revision of the platform, but also projects like 8 Updates project, where we work on the updates in the open, or the 7 Updates projects, where I'm one of the project leads, where we work on the Java 7 updates in the open with the community, where we take contributions in form of bug fixes, for example, or features back into the JDK code base. And one good example there is the PowerPC port I just mentioned before, but done by IBM and SAP. When IBM and SAP first thought about working on something like this, their idea was to contribute some of their fixes back, but by being able to complement each other, because IBM have their own VM, SAP has a hotspot port, they were able to pull a whole port out of existing source code in there, enable the community to participate, enable Linux distribution to package this for 64-bit Linux, enable others like Google to come in and provide their own port to, I think, PPC64LE Linux. So there is a different 64-bit PowerPC thing depending on, whatever you use. Doesn't matter. But the thing is, all of a sudden, we had something actually worked, that was tested, that was maintained, that could be integrated into Java 9. And then after that was done, could be backported into Java 8, so that when you check out JDK 8 update 20 or update 40 source code today, you'll find this port in there. It's going to build, it's going to run if you run one of those systems. It's not something you can get from Oracle, so it's not a product from Oracle that you can download, a JDK for X, but it's an OpenJDK, so the community can actually participate and work on this. So I mentioned major RI projects, I mentioned updates projects, and updates are fun. They're like sausage making. But there are also all kinds of other fun projects that explore features. And one of the things we do with the JDK is we try to avoid stuffing everything into one single project. So we try to work in a more distributed fashion and explain a bit why that's the case as we go on. And that means we try to implement features in their own projects because they typically interest a set of people, not necessarily everybody. And if something goes wrong, if it's not ready, well, then no harm done. Maybe it'll get into the next release. Some projects like that you may be familiar with are Project Lambda, where we developed this exciting new feature in Java 8, Lambdas, and pulled them into Java 8 when they were ready. Another project you may be familiar about here in the Eclipse land is probably Jigsaw, Modularity, which wasn't ready for 8, but still goes on as one of the projects working on for 9. But also more experimental projects, like, for example, Valhalla, a new project trying to address things like value types, or Sumatra, where engineers from AMD and Oracle are working on bringing Java programs to GPUs transparently. Or say more experimental ports like a BSD port. So in case you're running OpenBSD on a Spark, that's the thing, and so on and so on. So the projects address a whole wide area of things. And one of the recent things we've seen has been projects like Device I/O that target areas that are not classical in that sense, Java SE domains, but become more important as the embedded world and the SE world come closer together. So that's a new project that's been out there for the past couple of months now that basically targets new libraries for input and output from a whole variety of devices. And so, in a sense, you may have this mental image of the ideal open source project, right? It's like this space station from the 50s, Taurus, and there is palms inside and so on. OpenJDK is more like this, like the ISS. But it has two advantages. It exists, and it actually works, like the ISS. And so, how well does it work? It works pretty well. If you look at sites like OpenHub by, I think these days it's Black Duck, that aggregate statistics across different open source projects and communities, you'll see that this is actually from JDK 9, that over the past year, since we started using Mercurial back in 2007, OpenJDK has grown quite a bit to a bit more than 5 million lines of code. I guess a few million lines of comments, because Java developers are really good at commenting stuff. Thank you, JavaDoc. But also because a large chunk of the JDK is written in Java itself, almost 3/4. And there is a sizable chunk of C++ down at the hotspot VM level, and a bunch of other things we don't talk about so much, like XML, and assembly, and so on and so on. But interesting things are here. It has a pretty large established development team that's remained stable over the years, and has been growing in the past years actually, and has a stable commit rate. And so if you actually look at the way this has been going, the OpenJDK community has been not just great for developing code itself over the past years, and we've done a lot of work to make that easier, but also in enabling all kinds of users and participants to join and participate in earlier phase of development. So not just sending us patches, but also participating by giving us feedback, by participating in design discussions, and also getting insight into planning, which is also an important part of this. So for example, one thing you may not have noticed is that once Java 8 was released earlier this year, there was a whole flurry of books around Java 8. I think in Java 1 we counted something like 80 books. That's fairly good for a new technology. And something like that becomes possible because once you develop technology in the open from the start, it's much easier for others to do their part and socialize it. Similarly, one of the things I've been doing in the past year has been to reach out to different open source projects and get more involved with them with respect to testing. Because one of the advantages of doing things through OpenJDK in the open is that we can actually get much earlier feedback from our users about things that work or don't work. So basically, if we break Scala, it would be good to know that before we make a release, because then we can fix it, right? And breaking Scala is kind of bad. Nobody wants to do that. So we went and reached out to projects like Apache Lucene, like Solar, like Scala, like Groovy, Maven, and so on and so on. I think by now it's about 40 of them that are regularly participating in testing early access builds of JDK 8 updates and JDK 9, letting us know when things break, which doesn't happen that regularly, so that's good. But also, by doing it this way, we basically get the early feedback at a time we can still address it. And that means we can deal with issues that, as they come up, and produce much better releases. And that also makes it easier for the community to move on faster. And if you've been looking at the news in the Java 8 space in the past weeks, you've noticed a whole flurry of announcements from different projects and organizations about Java 8 adoption. I think TypeSafe had a survey, for example, where they celebrated their survey results as showing great adoption. The Clojure community just did a survey like that as well about 8 adoption, and a whole bunch of projects has already moved on to 8, like Scala has decided to base their next release 2.12, I think, on 8, or are actually working on making sure that they're ready to go. And so that's another side role of OpenJDK, this transparency around the evolution of Java that enables all these good things in the ecosystem to happen. But it's not everything. So it's not a floorwax, it's not a dessert topic, it's not all things to all people. One thing it's not actually a product. It's an open source community for open source projects. So if you expect something you can download and run, I have to disappoint you, we're open source. So most OpenJDK projects will only get source code, which is fine, right? Anybody can build source code, that's easy. You hit configure, make install, you're done. On Linux at least. If you're not on Linux, well, try Solaris or something like that. OS X is fine as well. Windows is a bit harder. I hear from people using Windows, but you know, who uses Windows here to develop anyway, right? Well, sorry. You should switch. Look, the majority can be wrong. But yes, open source. So binaries are typically provided by third parties. If you're using Oracle Linux, for example, there is an OpenJDK binary in there. And if you go to the install page of OpenJDK, you'll find a whole bunch of instructions how to install it on Debian, Ubuntu, Rail, Fedora, what have you, these kind of things. There is one exception, of course, as with many rules. That's the RI binary. As I mentioned before, OpenJDK also serves as a place where we develop the reference implementation, which is actually a binary you can run. So it's basically like the kilogram in Paris, the kilogram, the one you compare against. And that should be an object, not an idea, right? So it's, in that sense, the RI is actually a binary. But there is only one of those. So it's done at the GA date, basically. And it never gets updated because, of course, you don't go and update the kilogram, right? It stays what it is. That's its purpose. So you probably shouldn't be running that nowhere near production. But if you're building your own JDKs, it's a really good reference to compare against. And it's only open source code. Another thing that's probably a bit different in the early days. In the early days, we made the experience that Sun couldn't open source all the things it wanted or had in the JDK. Some came from third parties. So it had to drag around a bunch of binary blobs, which were quickly, within a year, excised from the OpenJDK code base, the need for them, thanks to contributions both from Sun and from the community to basically write parts that couldn't be open source. And ever since, we had no need to drag these things around. And having not open source components you have to have is a bit of a downer when it comes to collaboration, because of course, as soon as you try porting things, you don't have them. You have to work around these things and so on. So that's been something we have been very careful to maintain since, to make sure that when code goes into new projects, it's actually open source from the start and doesn't require third-party bits and pieces. And like I said, it's not a product. If you need products, you can find them from Oracle and others. If you need support, you can find them from people providing you the binaries, either from Oracle and who else. There is also a nice advantage here. By splitting, in this sense, the stuff you can run, like binaries, from the stuff you develop, like the code, you also have a nice separation between the needs of the users, who have problems like this doesn't work or doesn't link or whatever, from problems from people who actually are more concerned with moving the platform forward. They don't necessarily overlap very well. And so this helps quite a bit in keeping the OpenJDK mailing list very, very technical. And that means if you care about participating, you'll notice that it's very focused on patches, on changes, bug fixes, and so on, and not so much on discussing general Java issues, like what's my favorite IDE or whatever. If that's a question you have, not the OpenJDK community. Wrong place. But there are much better ones for that, like forums and whatnot, Twitter, what have you. So it's not all things to all people, but it's actually a good way to move Java forward. And this is interesting because I think on the embedded and IoT sides, we're coming to a place where there is certainly an expectation that there are billions of devices out there and more billions will come. If you look at surveys and whatnot, people are glad to tell you there's going to be lots of devices. And these devices, because Internet of Things means somehow connected and talking to each other and data, will have to do all these beautiful things, which means somebody will have to write applications for them to make them do all these things. And while there are millions of developers out there, and I think Oracle has a while ago put out statistics of 9 million Java developers and all that, the rate at which the number of developers grows worldwide is probably not the same as the rate as the number of devices grows worldwide. It's much easier to make devices than developers, in other words. Developing is hard, right? Right. Developing is hard. You have to go through a certain kind of education and learn stuff. And it turns out, at least in embedded development, it's even harder than that because you often are dealing with things like C and assembler. And C and assembler, as great tools as they were back in the 70s or 80s, tend to be, for most people, hard and error-prone to use, whether that's dealing with the problems caused by manual memory management in one area or another. It simply is not something that's, most importantly, very attractive to students anymore. So if you look at statistics from universities in Germany or US, you'll notice that places that teach C and C++ as their first languages have basically dropped down to just very few of them. And that means those millions of developers that may or may not come probably won't know C or assembler as a first language. And I think that's quite interesting because Java traditionally has done really well in places where C and C++ have been a good enough solution for a while. In particular, not just because it's a nicer language and all that, I have to say that, right? But it also because it's structurally set up in a way that's actually quite nicer. It provides major updates to languages and API every couple of years rather than once in a decade, as it's typically the case for C. It has the specifications, which are accompanied by reference implementations and test suites, so that now that Java 8 is released, everybody does Java 8. There is no, well, Java 8, but a few bits left out, as is the case in the C world. Compatibility is a big deal in Java worlds, in particular backwards compatibility, which ensures that people's investment in their technological stacks, in the libraries and so on, remains useful over time. You don't have to rewrite your application every 2 years just because the JDK has moved on, right? So in particular because JDK brings in so many standard libraries, you don't have to plug different bits and pieces together with different API evolution strategies. So you can rely much better on backwards compatibility. And why this matters, a good reason why this matters is, for example, look at Python. In the Python world, there is Python 2, there is Python 3, and a huge schism, right? Python 3 isn't backwards compatible. And that means the community is now split between Python 2, which you use if you have work to do, and Python 2, which you use if you have time or passion, or both, right? Great stuff, but splitting the community in that way turned out not to be the best strategy ever for the Python community. And so the backwards compatibility turns out to be a pretty good strength for moving platforms forward. Concurrency, also a big deal, because as we move into this world where multi-core processors are standard, they're everywhere, how you deal with concurrent applications, how you make them performant and useful and correct becomes a harder thing to solve, right? So more important. Portability by design is something Java does pretty well as well. It's been designed from the start to work well across different operating systems and different CPU architectures. Whereas, your portable C program, well, let's just say if you run your typical portable C checkers on arbitrary people's programs, it's fun. It's fun. It turns out that having chars that are sometimes signed, sometimes not signed, can trip people up. Who would have thought? Also, excellent tooling, another Java strength. And in particular, I think that the most important point is a strong community that's not fragmented between different, revisions of the language, but basically is in one place and moving forward in a similar direction. And one last bit that I find most interesting about all this is that if you look at the numbers, if you look at the stats, if you look at the stats for the free implementations in the embedded space, that's typically GCC, the new compiler collections, that contains compilers for Java, I guess, and C and C++ and Fortran and Ada, and these days also Go. If you look at the numbers for GCC, the number of people working on GCC, committing every month, has remained quite stable for the past 15 years at somewhere above 50. If you look at something like OpenJDK, which contains compilers for Java, and that's about it. Well, there's also NAS from JavaScript, but the number you can see has, of course, remained stable during the Sun years, but once the Oracle acquisition completed and things stabilized, it's actually shot up to way above 100, and it's currently at around 100 people committing every month into the JDK9 repositories. So it's a very different level of investment, a very different level of focus in the whole community than in the C and C++ world, which I think is very exciting. So I think it's a very exciting time to be working on Java as this IoT and embedded explosion happens. And with these few numbers and things to think about, yeah, I'll just say there are many things in your still life. If you want to connect them, consider going with the Duke. because it fits in many different places depending on your size, footprint, servers, embedded, small embedded, down to megabytes and kilobytes. And with that, I think I'm out of time. So if you have questions, I'll have answers outside. Thank you very much.